The story of steel begins long before it rises into the great structures of our modern world. It all starts with iron ore, dug from the Earth's crust, rocks rich in oxides that hide metallic iron. From the pit, the ore is crushed, concentrated, and sent to the furnace. It is blended and prepared to be combined with two other vital ingredients. Coke, a form of processed coal, acts as both fuel and reducing agent. Limestone is added as a purifier, ready to capture unwanted impurities. All three are fed into the blast furnace, an ancient idea refined during the Industrial Revolution. Inside, temperatures soar beyond 2,000 degrees Celsius. The coke burns, reducing the oxides and releasing molten iron that gathers at the furnace base. The result is pig iron, a glowing liquid material that flows like a metal river. Yet pig iron is only the beginning. With high carbon content, it is hard and brittle. Alone, it cannot meet the demands of modern construction. Pig iron must be transformed, sent onward to the steelworks where the real metamorphosis happens. This is where heat meets chemistry, and crude metal becomes a material of civilization. Precision matters, temperatures, flows, and chemistry are all controlled. These methods evolved over centuries, building on craft and science. It is a spectacle. Fire, sparks, and flowing light that seem almost alive. Soon, oxygen will join the scene to reshape the metal at its chemical core. From buried ore to molten pig iron, this first stage sets the stage for steel's true transformation. This is only the beginning. Impurities form slag, waste that must be separated for quality metal. Samples are tested constantly to guide the next steps. A continuous dance of input and output keeps production steady. Safety, skill, and engineering combine at every turn, and so the furnace keeps forging, day after day. Next, the conversion into steel, the moment pig iron is reborn. We move now into the heart of the steelworks. Prepare for a chemical storm of light and energy. The next phase will define what steel can become. Purification begins now. With pig iron ready, the next step is the steelworks, where metamorphosis happens. Molten pig iron is poured into a massive steel vessel lined with refractory material. Powerful jets of pure oxygen are blown into the metal. This burns away impurities and reduces carbon in a chemical shock. Carbon reacts with oxygen, forming gases and leaving purer iron behind. The reaction is violent and beautiful. Flames and sparks dance across the vessel. Impurities like phosphorus, sulfur, and silicon are removed as slag. Tests ensure the carbon content has dropped to target levels. Now the metal can receive additions, nickel, chromium, manganese, to tailor properties. Each element changes strength, corrosion resistance, or flexibility at the micro level. The plant becomes a theater of controlled violence, a statement of human control over matter. Skilled operators time every blast, every lance to create consistency. Once purified, the molten steel is cast into blooms, slabs, or billets. Then it is shaped, rolled, forged, and heat-treated to final form. Additions can make steel stainless for hospitals and kitchens. Other alloys become ultra-strong for aerospace and high-temperature applications. Every lot is tested mechanically and chemically to meet design specs. Traceability ensures the right steel goes to the right job. Metallurgy blends chemistry, engineering, and craft, people designed for purpose. Training and experience keep plants efficient and safe. From this process emerges a purer, stronger metal ready to serve many industries. Ships, rails, and cars all rely on precisely made steel. At the converter, we witness steel find its identity. From impurity to design, steel's possibilities expand. Each mill run refines steel to precise specification. Certification and standards follow each batch. Behind every ton is a team ensuring reliability. Then steel joins the supply chain, ready for construction and invention. Freight moves it across continents. Its impact stretches beyond the plant to the city and the world. Steel becomes the backbone of civilization. We now look at how steel reshapes society. Every beam and rail tells part of the story. People live, move, and build upon it. Now, the global reach of steel. Steel shaped the Industrial Revolution. Engines, rails, and ships powered progress. It built the machines that transformed production and society. Bridges span oceans and rivers thanks to steel's strength. Skyscrapers rise on steel frames, defying gravity and reshaping skylines. Rails knit continents together, moving goods and people. Automobiles rely on pressed sheets and safety cage structures of steel. Steel has powered warships and industrial fleets across eras. Its reliability is in joints, rivets, and engineered connections. In hospitals and kitchens, stainless surfaces keep environments sterile and durable. Public transit rails and bridges carry daily life. Rebar embedded in concrete gives buildings the ductility they need. Steel frames go up quickly, shaping the built environment. Steel underpins trade, industry, and the logistics that drive economies. Cities expand vertically and horizontally on steel's shoulders. Adaptations like stainless steel and special alloys meet changing needs. Steel builds renewable infrastructure too, towers, blades, and support systems. Steel can be recycled countless times, a rare material of permanence and transformation. The cycle of steel preserves value and reduces the need for virgin ore. Steel towns and supply chains shape communities and livelihoods. Engineers and builders design to maximize safety and utility. From monumental bridges to delicate architectural forms, steel enables design freedom. Its versatility reaches from heavy infrastructure to elegant facades. Globalization owes much to steel. Standardized components move worldwide. Automation and precision manufacturing scale production efficiently. Every rebar, rail, and beam is proof of steel's importance. Without it, urban growth and modern engineering would be unthinkable. Steel is both permanence and transformation, a material that adapts with us. Ultra-strong alloys go into aerospace, pushing boundaries of speed and safety. Steel enables rapid transit that connects people and economies, and its recyclability offers a rare environmental advantage. Ahead lies innovation and responsibility. Now we consider the future of steel and the planet. The choices made in steelmaking will shape decades to come. Though often overlooked, steel is one of the most sustainable materials humans create. It can be recycled countless times without losing properties. New techniques use green hydrogen to reduce iron ore instead of coke. This replaces carbon-intense steps and drastically lowers emissions. Pilot plants and retrofits are already proving the concept. Data and design are steering steel toward a sustainable future. Steel will be essential in electric cars and renewable energy systems. From turbine towers to offshore foundations, steel supports clean energy. Circular models extend lifespan through repair and reuse. Prefabrication reduces waste and speeds construction. Steel will continue to enable large-scale infrastructure worldwide. Even space missions depend on advanced alloys and structural steel supports. New green factories bring jobs, training, and renewed communities. Human ingenuity propels the transformation. Reducing carbon in steelmaking is vital to meeting climate goals. Industry, governments, and researchers must collaborate at scale. Smart infrastructure, sensor-equipped bridges, and adaptive materials are on the horizon. Steel remains a common thread across technology and the built world. The journey from pig iron to steel is more than metallurgy. It is how humanity transformed nature into progress. Each spark of molten metal tells a story of invention, labor, and hope. From ore to alloy, from furnace to skyline, the cycle endures. Steel is durable, recyclable, and essential to our shared future. The future is forged together, one responsible choice at a time. Thank you for watching. Subscribe for more stories of materials and innovation.